All right, so if you would please find your textbooks, and we are on page 127. So we're looking at the assignments page. We're going to use this today as our notes. So we're going to go through it together. All right, so the first one is define constant proportionality in your own words. Provide a specific example of your definition. Well, to me, the constant of proportionality is also the constant rate of change. It is my k variable. Okay, this is when I have y over x. This is my unit rate, in other words. All right. Let's look down at the practice. So analyze each table or problem situation to determine if the relationship is proportional and state a constant of proportionality if possible. Okay, so let's take a look. 7th graders to 8th graders. I have 7, 9, 14, 9, 21, 11, and 22. All right, so let's take a look. We're going to look at our K column here. Remember, our X column is always first and then our Y. Okay, so I'm going to extend my little lines here. Well, I'm going to have 7 over 14, which is 0.5. That's 1/2. No, wait. I need to flip that over. Not 7 over 14. That's 14 over 7. Y over X. Sorry. Ms. Roberts has got to remember. So 14 over 7 is 2. 21 over 9. 22 over 11. So 22 over 11 is 2. And 21 over 9, that's not going to be 2. That is going to be 2.3 repeating. So do I have a constant rate of change where all three of my numbers are the exact same? No. So is A proportional relationship? No. So not proportional. All right, a baby blue whale weighs 5,520 pounds at birth. After 2 days, the baby weighed 5,710 pounds. After 14 days, the baby weighed 8,180 pounds. Okay, so I want to know, is this situation a proportional situation? Well, before I even do any math, we have to think about this. All right, I know to be proportional, 3 things. Let me get you my 3 little rules up here. 1, I have to be a straight line. Okay, when I graph these numbers. 2, I need to start at 0, 0. And then 3, I need to have a constant rate of change or constant of proportionality, COP. Okay, so that means at some point, one of my little coordinate points here has to be 0, 0, which means I have to start at 0. When X is 0, Y has to be 0. Let me ask this. It is 5,520 pounds at birth. Okay, when a baby is born, when you're born, when any baby is born, is a baby born weighing at 0 pounds? Well, the answer is no. The baby is not born weighing at 0 pounds. So for this problem, it cannot be proportional. Because the first thing I need to know is, can I start at 0, 0? And the answer is no, I can't. So it's not going to be proportional. We can go through and we can do the math. So let's say at 5,710 minus 550, 20. So within 2 days, I've gained 190 pounds, so divided by 2. So that's roughly 95 pounds a day. So 95 times 2, okay, is 190. So 5520 plus 190 gets me 5710. Okay, well, 95 times 14 is 1330 plus 5520. That doesn't equal 8180. Okay. All right, number 2. The number of bricks her crew installs varies directly with the number of hours they work. All right. So I'm going to say hours is X and bricks is Y. Let's find our K column here. Okay, so to define variables for quantities that are changing in the problem situation, Well, my variables that are changing are hours of worked versus number of bricks. So however many hours I work, that's going to be how many bricks I'm going to install. So I've just defined those. Analyze the table to determine the constant of proportionality. Well, that's what we're going to do right here. So I'm going to have 1680 over 8. I'm going to have 1470 over 7. And then 1260 over 6. We're going to use our handy dandy calculator. And I'm going to see that I can do 210 bricks an hour here. 1470 divided by 7. 210 bricks here. Well, we're doing pretty good here. Let's see. Can we do it? Nope, not 210. 6. And look, our constant of proportionality, so for B, our K value is 210. This means, so what does the constant of proportionality mean in your situation? This means for 1 hour is equal to 210 bricks. That I can lay 210 bricks in 1 hour. So write an equation to show the relationship between the number of hours worked and the number of bricks installed. Okay, well, every single hour here, I multiplied it by 210 to get Y. So I'm going to have Y is going to equal 210x, because if I work X number of hours, how many bricks am I going to lay? All right, so use your equation to determine the number of bricks Maya's crew can install in 505 or 5.5 hours. So I'm going to have, let's see if I can get it over here in the small bit. So Y is equal to 210 times 5.5. And this is going to equal, I'm going to use my calculator here, 1,155 bricks. All right. Use your equation to determine how many hours it will take Maya's crew to install 840 bricks. Well, I know Y, so this is my Y. So I'm going to have 840. Let's see, we're not using number 3. So I'm going to mark this out. So I have 840 is set equal to 210x, and I want to solve for x. So I need to do the opposite of what I see. Divide by 210 to get x is going to equal, let's use our handy dandy calculator here, that it's going to take me 4 hours to install that many bricks. 4 hours. All right. Let's flip on over to number 4, please. Let's see. All right, those aren't that important. Okay. The following recipe to make 6 cups of perfect lemonade is 1 cup of sugar, 1 cup of water, 1 cup of lemon juice, and 4 cups of cold water to dilute. All right. You want to analyze the relationship between the number of cups of sugar and the number of cups of lemonade. All right, so to find your variables for the quantities that are changing in your problem. Okay, so what we need to do is we're going to need to let S equal the cups of sugar, and we're going to let L represent the cups of lemonade. All right, so all I did was just give what I'm looking for. So I want to know the difference or the relationship between cups of sugar and cups of lemonade. So I said S is going to equal sugar, and L is going to equal cups of lemonade. So set a proportion for the ratio of cups of sugar to cups of lemonade. Well, I want to make 6 cups of lemonade. So for every 6 cups, it's 1 cup of sugar. So I'm going to have 1, what is it? There we go. So we're going to have 1 cup of sugar over 6 cups of lemonade. So 1 cup of sugar over 6 cups of lemonade. All right. Use your proportion to write in equations for the number of cups of sugar based on the number of cups of lemonade. All right. So what I'm looking at here is I want to know what is my constant of proportionality. What is my K value? Well, right now my K value is 1 over 6. Okay. So if I'm looking for the cups of sugar, I'm going to use my K value of 1 over 6, and I'm going to multiply it by L, because use your proportionality equation for the number of cups of sugar based on the number of cups of lemonade. So for however many cups of lemonade I have, multiplied by this ratio right here that we just found, that'll get me the number of cups of sugar. All right, so what is the constant of proportionality in my equation? Well, it is 1/6. And that means, what does it mean in words? That for 1 cup of sugar, you will have 6 cups of lemonade. That's what it means. So use your equation in C to write an equation in the number of cups of lemonade based to the number of cups of sugar. Actually, nope. Mark that one out. Don't do that one. Don't do that one. And then mark out F. Don't need that one. Don't want to confuse you. All right, number 5. Dudley and Bob monitored the distance their pet turtle could walk in a certain amount of time. The results are shown in the table. The table of values represents a proportional relationship. So define the variables for the quantities that are changing in the problem. Well, time is changing at X and distance is Y. All right. Write an equation for the distance traveled by the turtle based on the number of minutes. Well, I need to find my constant of proportionality. Okay, so let's create our K column again. And remember, K is Y over X. Okay, if you guys want to go ahead and pause this video, and I want you guys to find your I don't know how many Ks you're going to have, but find me your K value. Create your K column, and then find me the K value. 72.5 over 25. All right, so I'm going to use my calculator here divided by 5. 2.9, 40.6 divided by 14. 2.9, 55.1 divided by 19. 2.9, 72.5 divided by 25. 2.9. All right, so I found my K, and I need to write the equation based on the turtle. So I need to write my Y equals K times X equation. Okay, except this is going to need to written in distance versus time, which I'm going to propose a new equation to you. D equals RT. All right, this equation is set up and represents the exact same thing as this. You guys will hear it as distance equals rate times time. All right, this is usually the only equation that is used when you're dealing with distance and time. Now, my rate and my K value are the exact same number. I just need to sub D in for Y, so I'm going to have D is equal to, well, my rate, we said it was K, is equal to 2.9 T. So that for every minute, I'm going 2.9, and that is equal to my distance. Okay. What is the constant of proportionality in your equation? Well, that is equal to 2.9. So that means I'm going 2.9 inches every minute. I'm going 2.9 inches every minute. All right, let's see. Use the equation in B to write the equation for time. It would take the turtle to travel a given distance. Let's see. Nope. And guess what? We get to mark out D and E again. Get to mark out D and E again. All right, and then do I want to do the stretch? No. All right, if you guys have any questions, please let me know.